Тынг, лайк числа.
Okay, so starting out a new channel, what do you need? Good, useful content. I've got something here that's going to change your life. Seriously. So this is a way for anyone, doesn't matter if you're no good at math, doesn't matter if you hated math in high school, anyone can multiply, divide, exponentiate, square root, cube root, whatever root, any two numbers in your head. It's true. Let's go. All right, so this is not something original to me. This has existed in engineering circles for a long time. But I'm presenting it for you because this is going to be useful for pretty much everything that happens on this channel going forward. So this will get you more familiar with numbers. It'll give you a more feeling, a better intuition for how numbers really work. Okay, so examine this chart here. We got an index column in blue. This goes 0 through 10. And then we got a number column here for real actual numbers. So each number going up one notch is about 1.25 times the previous value. Notice if you go up 3 notches, 2, 4, 8, it doubles about every 2 notches. And then, of course, when you go up 10 notches, it goes up by a factor of 10. All right, so this is something called a logarithm. All right, you probably remember that word from, I don't know, maybe high school math. Sounds scary, but it's really pretty basic. And it's something we see all the time in day-to-day situations. For example, let's see, an earthquake. You know, there is a 6.5 earthquake in Southern California or whatever. Each time you go up 2 numbers on the magnitude moment scale for earthquakes, you're talking about an earthquake with 1,000 times as much energy. So between a 6.5 and an 8.5 is 1,000 times more energy in the earthquake itself. People say, hey, I closed a 6-figure deal. Going from a 6-figure to a 7-figure deal is a factor of 10. Even like the questions on Who Wants to Be a Millionaire. The dollar amount that goes up for each question that you advance, the dollar amount keeps going up too. So we see a similar thing here. And it's really not mysterious at all. So how can you construct this table? Well, a little secret here. I actually don't fully memorize this. So I have a printout of this table here, and I'll make a downloadable version of it. I'll link to it below. But basically, you write indexes 0 through 10, and then the first index for 0 is 1, and the index for 10 is 10. Now, since we know it doubles every 3, you can easily construct this by skipping, get the 2, 4, and the 8 in here. It also halves when you go down 3 notches. So you get 10, 5, 2, 1.25. And then the only kind of thing you have to remember is right in the middle is very close approximation of pi, about 3.1. And you can double that to get this one 2 pi, or properly called tau. And half of pi is about 1.6. A very close approximation also of the golden number. All right, so let's do an example of how this works. We're going to get fluent in transposing from real numbers to indexes. Then we can do things with the indexes, and then we can transfer back to real numbers to get our answer. So say you had a 5 ohm resistor. We would say that's an index of 7. Let's do another example. What if you had a 15 ohm resistor? Well, this scale keeps going up here, 1.25 bigger each time. So 11 would be 12 and a half. 12 would be 16, 2.5, 25 ohms, 31.4 ohms, 40 ohms, 50 ohms. All right, so 15 would be just a hair under 12 as an index, right? 50 would be an index of 117. All right, so let's look at a few more examples. Let's say you wanted to compute 2 times 4. You could probably do that in your head, but it's a good way to get used to the system. Okay, so 2 is an index of 3. 4 is an index of 6. Now, the trick is, in a logarithmic scale like this, multiplication of real numbers is just addition of numbers in the index. So 3 plus 6 is 9. We go back to the real numbers, and we get our answer 8. You see how that worked? Let's look at another one, 2 pi 5. Let's say we need to compute that. Again, simple. 2 pi is about an index of 8. 5 is an index of 7. So 8 plus 7 is 15 again. So that puts us, we wrap around here into the teens. That gets us up to 15. And our answer is about 31.4. How accurate is that? Let's check Wolfram alpha here. Oh yeah, we get 31.4. Let's look at another more complicated one. What if we wanted to compute 1 over pi? Well, 1 over pi, we can just flip the negative sign on our index. So pi is an index of 5. If we flip that around, it would be -5, right? So if we consider how the scale goes down each time, about 80% each time, right? So this is like 1, index of 0, -1 is 0.8, -2. So the 1 over pi would be about 0.314. Now, is that accurate? Let's check again. It's about 0.318. So our estimate was very close here. Nailed two decimal digits of precision. All right, how about another one? Square root of 2 pi. How about that? When you're in the realm of indexes, exponentiation or square cube rooting is multiplication or division in this scale. All right, so 2 pi is an index of 8. Square root is 2. Divide by 2, 4. The square root of 2 pi is about 2.5. So let's check the math on that one. Square root of 2 pi is about 2.5066. So again, really accurate result. So you can keep getting progressively more and more complicated here. How about square root of 1 over e? We'll do this one not quite in our head because we're practicing here. E is about 2.71. So the index of that is 4 and change. That's the technical term for it, 4 and change. All right, so 1 over it, so that gives us to -4 and change. And square root takes that in half, and that takes us to -2 and really small change. All right, so what's -2? 0, 1, 2, 0.63. A little bit changed, so we get a little bit farther here, 0.60, maybe 0.61. And let's see what Wolfram says about that answer. How accurate did we get? 0.6065. So right, our estimate of 60 or 61 was right in the ballpark. Okay, one more nice juicy one. This is an actual formula you might see when building, say, a Tesla coil. So our formula is 1 over tau, proper notation for 2 pi, of course, square root of LC. And L is 10 microhenries and C is 1 nanofarad. So let's figure out what the indexes of these would be. So nano is 9 decades, right? So this would be an index of -90. 10 micro, 1 micro would be 60, right? But it's 10, so that's -50 is the index of that. Now we multiply, we add these together, we get -140. To take the square root, that takes half of that, so now we're at -70. And multiplying by tau is addition, right? So from -70, we add an index of 8. So now we're only at -62. And the reciprocal flips the sign, leaving us an answer of +62. What's +62? That's 1,000,000 times 1.6. So about 1.6 million, in this case, cycles per second. How accurate is that? Right, I'm going to put a few more problems in the notes underneath this video. If you want to try some more, put your best answer in the comments. Give me the index of the answer and the real number of the answer. See how it works. If you like this, please tell somebody about this. Subscribe to find out when new videos come out. Check out the Geek Thoughts web store. I'll put a link to that. Yeah, hope to see you more. Thanks.
Tesla Nomicon.
Featured book. So to start this off, the featured book is going to be Calculus Made Easy by Sylvanus P. Thompson. Now, interesting guy. He was actually a contemporary of Tesla, and yet his book on calculus is just one of the most understandable, humble books you will ever read. This has been hugely influential in my life. He starts off saying, "What one fool can do, so can another." And he goes on to demystify calculus, which he calls something that is just presented in terms that deliberately obfuscate it and make it difficult to understand, which I totally agree with. So check out the link below to find this book. One word of caution, I have heard that the ebook version of it has poor formatting, so you might want to stick to paperback for this one. But yeah, I've purchased this multiple times because I keep lending it to people and not getting it back. So check it out.